There we go. All right. Awesome. It's great to be back here in person. Thank you for having me. It's great to see everyone's faces. Thanks for coming to my talk, The State of JavaScript Supply Chain Security in 2022. So that intro was great. So just to, I guess, go over it again, started this company called Socket, which I'll touch on a little bit at the very end, but try not to make it too much about that. I teach web security at Stanford and wrote a bunch of NPM packages over the years. And the two you might have heard of are standard.js and WebTorrent. In the past, I was actually on the board of the Node Foundation and also a consultant for the Silicon Valley TV show, which was pretty fun, actually. Yeah, so what's our agenda for today? So I'm going to start by telling you a story of a real supply chain attack that happened not too long ago, and we're going to go over some of the attack code just to kind of get a taste for what does an actual attack look like. Then we'll talk about why is this happening now, so sort of the trends and kind of causes of the increase in supply chain attacks that we've been seeing. And then we'll dig into actual techniques that supply chain attackers use. And finally end with tips for how you can actually protect your app, as well as, I guess, kind of a wish list of features that hopefully we can get into the language and into Node and into NPM to help improve security across the ecosystem. So let me tell you a story. On January 13th, 2012, over 10 years ago, a developer named Faisal Salman published a project called UA-Parser.js. It was a user agent string parser, and lots of people found this project really useful. Over the next 10 years, he continued to develop the package with the help from many open source contributors, publishing a total of 54 versions. The package continued to grow in popularity, eventually reaching 7 million downloads per week, and it was used by 3 million GitHub repositories, so just a massively popular package. Let me tell you a different story. On October 5th, 2021, on a notorious Russian hacking forum, this post appeared. And as you can see, there's a hacker attempting to sell the password to an NPM account that controls a package with, suspiciously, over 7 million weekly downloads. And a couple weeks after this post appeared, on October 22nd, UA-Parser.js was compromised. We don't know for sure that the two events are connected, but it's pretty suspicious, to say the least. So 3 malicious versions of this package were published. Malware was added into these versions that would execute immediately whenever anyone installed one of these versions. So now let's actually dig in a little bit to the package to see what exactly the attacker did once they got the password to this maintainer's account. So the most important thing, the most common thing you'll see in supply chain attacks is the use of install scripts. This is a feature in NPM that allows a command to run immediately upon a package installation. And you'll see here this /b flag is actually just a Windows trick to kind of start the script in a new hidden terminal to make it even a little bit more sneaky on Windows. Now, if we actually go into that script to see what it's doing, I'll draw your attention to just a few parts of the code. So you'll see that it actually does different things on each platform. Mac users are pretty lucky in that it actually does nothing on Mac. They didn't bother to make a Mac payload. On Windows, though, they weren't so lucky. So the attacker launches this batch file here. And on Linux, they call this function, which also launches a shell script, preinstall.sh. So let's dig into that shell script to see exactly what the attacker wanted to do here. So the first line is pretty interesting. So this is going out to the network to fetch the user's country based on their IP address. And it's specifically interested in whether the user is coming from Russia, Ukraine, Belarus, or Kazakhstan, in which case it aborts the script. This is actually a pretty common technique in that malware authors use. They usually don't want to antagonize their local law enforcement by attacking users in the country that they operate in. And so it's implied here that the attacker comes from probably one of these countries or is part of a group that operates in these countries. So assuming that the IP or that the country, we get past that if statement there, the next thing that it does is it checks to see if the malware is already running on the machine, in which case it will exit early. If it's not running, then it goes out and downloads this file from the network, makes it executable, and then starts it. And you might tell here, based on the command line arguments, you can kind of get an idea of what is it doing. It's a Monero miner. You know, they got to go for that sweet, sweet cryptocurrency. And so that's what this is all about. On Windows, it was very similar. I'll just draw your attention to kind of one difference on the Windows payload. Here, they downloaded a DLL file in addition to the Monero miner, and then they registered the DLL in Windows. And that extra step was designed to steal passwords from 100 programs on Windows, as well as the Windows Credential Manager. So, yikes. So the aftermath of this was that this was published for about 4 hours before it was caught by the community. Anyone who installed the package during that window would have been compromised. Any software builds done in projects that weren't using a lock file would have been compromised. And anyone who updated this package to a new version or merged a Dependabot PR during this time window would have also been compromised. And so, you know, this is just one example. But in the last 30 days, there's actually been hundreds of packages removed from NPM for security reasons. So the trend seems to be accelerating, and attackers are taking advantage of our open ecosystem and our trusting natures as JavaScript developers. Just a few other examples that have happened, you know, even more recently than the story I just told you. In January, a maintainer actually sabotaged their own packages by adding code to denial of service, added denial of service code into their projects as a protest. And in March, there was what's been dubbed protestware, which is when a maintainer sort of uses their control of their package to publish, code to draw attention to something. In this case, the maintainer of Node IPC added code that would delete your hard drive if you were suspected of being Russian. They did this by overwriting files with a heart emoji. And then following that, there was other instances of maintainers doing less malicious, less destructive things, but also probably still unwanted by most users, such as like redirecting visitors to other URLs and adding extra code into JavaScript bundles that the user probably didn't expect to be there. So, why is this happening now? I think there's 4 main reasons. The first is that open source has clearly won, and it's just being used everywhere. And this is kind of an obvious one, but gone are the days of copying code snippets from Stack Overflow or reinventing the wheel by rewriting everything in-house. 90% of an app's code comes from open source. And that enables teams to build applications in days or weeks instead of in months or years. And open source works because anyone can inspect the code, anyone can contribute, anyone can publish a package, and this all works because open source communities are trusting by default. And good contributors are rewarded with recognition and eventually publish rights. I'm preaching to the choir here, but you all know this. The second reason is that the way we write software has changed pretty dramatically ever since the advent of NPM, really. So NPM solved dependency hell and made it really feel costless to add additional dependencies to a project. And ever since then, we've really started using dependencies quite liberally. And that leads to a lot of transitive dependencies in the average project. So if you run create React app, you'll get nearly 1,400 packages just out of the box. And that's just a hello world to get started with React. And if you look at a real-world app, in this example, let's look at Discord, which is an Electron app, very real-world app. This has 19,000 plus packages. And if you look at all the commits across all those packages, it has 300,000 plus contributors from 206 different countries. So it's just like very sprawling and very, very wide-reaching. And this is cool in a way. This is the power of open source, right? But this is also risk, right? All these different contributors are sources of risk. So a 2019 Usenix paper found that installing an average NPM package introduces an implicit trust on 79 third-party packages and 39 maintainers, creating a surprisingly large attack surface. And so this leads to, this is actually a visualization of a real package, Webpack. And what you're seeing here is peeling back the layers of each package. So the gray boxes are packages, and as each layer gets peeled back, you'll see that the purple boxes within are files. And so what we're doing here is traversing the dependency tree one layer at a time and kind of unwrapping each package to see what's inside. And you can just get a sense here for the number of different packages involved in just this one dependency that you might have in your application, Webpack. So So yeah, this is just a, kind of a big change in the way we write software that is adding to this trend. The other reason is no one really reads the code. We download code from the internet written by unknown individuals that we haven't read, that we execute with full permissions on our laptops and servers where we keep our most important data. So this is pretty much a miracle that this works, and that it's continued to work for this long, frankly. And I'm sure I'm not the only one guilty of merging depend-about PRs without looking at what code actually changed. Even if you were try to read the code, attackers often publish different code to NPM than they do to GitHub, and NPM doesn't guarantee that the code in a package matches the code on GitHub. So even if you try to do the right thing, it's pretty hard here. And to some extent, we can rely on Linus's law, that says, given enough eyeballs, all bugs are shallow. Who here's heard this quote before? Over time, the community will find this stuff. If there's malware in a package, we can rely on it eventually being found, but the issue is it's like eventual consistency. There's no guarantee that this will be a quick process. And the question is really how much damage will happen in the meantime until this stuff is found. A 2020 paper found that on average, a malicious package is available for 209 days before it's publicly reported. Now, to be clear, these are packages that are not the headline-grabbing ones that have tens of millions of downloads. These are kind of the long tail. But still, this is 209 days during which if you make an incorrect npm install command, it can end extremely badly. And then this was kind of replicated again in a 2021 paper at NDSS, a prestigious security conference. They found similar results, including that 20% of malware persist in package managers for over 400 days and have more than 1,000 downloads before they're removed. Okay, so those are kind of the reasons I think that we're seeing more of these attacks. Now let's actually dig a little bit into how does a supply chain attack actually work. So I'm going to cover 6 TTPs, or tactics, techniques, and procedures. This is a term from the security industry. We're going to go through these 6 kind of approaches that attackers have been using. So the first is hijacked packages. These are the ones, this is the source of the attacks that you see a lot in the news. So anytime you see that a package has been taken over, it's usually because the maintainer made a mistake somehow. They used an incorrect password. They added a maintainer who wasn't trustworthy, and so on and so forth. There's a whole bunch of different reasons this can happen, but the chief one is really maintainers choosing weak passwords, giving access to malicious actors accidentally. This is hard. This is hard not to do because this is the way open source works, right? You add people when they're making good contributions. This is just kind of inherent to kind of how we do open source. Maintainers can get jaded and become malicious actors. Maintainers can use their packages to insert protest code. Maintainers can get malware on their laptops. And the last reason is actually that NPM doesn't really enforce 2FA correctly across the board. They're starting to improve this, and I think we're going to hear more from Miles tomorrow about the recent work that GitHub is doing in this regard. But yeah, as of today, 2FA is not enforced across the board, and so if you use a weak password, then a package can get taken over. Second, typo squatting. So out of these 2 packages here, one of them is real and one of them is fake. Can you tell which is which? Probably not. It's pretty tricky, and in fact, actually, the real one is the one that I wouldn't have guessed is the real one. It's the proxied name. And if you install the wrong one here, you're going to get, this nasty install script is going to run on your machine. And if you open up that file, let's take a look at what's inside. Yeah, probably don't want to be running this on your machine, even if you don't know what it's doing. It's probably not good. So this is a big attack vector, typo squatting. Next, dependency confusion. So this one is kind of closely related to typo squatting, but it's a little different. So this happens when a company publishes packages to an internal NPM registry and uses a name that they didn't register on the public registry. So then an attacker can come along and register that public name, and then their internal tools might make the mistake of preferring the public version of the package instead of the private version that they intended to install. So there's actually, if you look through recently deleted NPM packages, you can see a bunch of likely dependency confusion attacks. So these are just some that we picked out from the feed of deleted packages. These all have names that look like they're intended to conflict with internal company names. So you can see Yahoo, URID, 18F, Palantir, DuckDuckGo, Shippo, all these companies. These look like package names that may be conflicting with internal names that were published to the public registry. And here are a bunch more. These go by all the time. If you look at this feed, these are constantly getting published and removed. Fourth is install scripts. So we already mentioned this before, but most malware is inside install scripts. This 2022 paper found almost 94% of malicious package had at least one install script. And unfortunately, install scripts do have legitimate uses, so it's not just an easy solution to disable these and fix all of your problems. As we've seen before, this is the line here. This one's actually pretty interesting. It has 3 different attacks that it's trying to pull off in parallel. We'll dig into those files in a second. So the 5th technique is data exfiltration. So this one is pretty common, and we'll actually dig into it now. So if we open up these files here, you'll see that this is a very straightforward data exfiltration. It's just making an HTTP request, and then the data that it's sending it off to this URL here, and then the data that it's actually collecting is process.env, which is your environment variables. So that'll include tokens and auth stuff to different services. And this is actually surprisingly common in the removed packages on NPM, this exact type of code. It's really not that sophisticated. It's just people putting stuff in there and hoping that someone's going to execute it so they can get some AWS credentials or something like that. They also used a kind of an additional technique in another file that they ran. This is a pretty clever one. So they're using DNS here in case you have a firewall that would block HTTP requests. They will attempt to use a DNS request. So they create a DNS resolver, and then they gather the environment variables and then place them into the subdomain of a domain that they do a lookup on. And that causes the data to go out as a DNS request. And then they loop over all the environment variables and do this for each one. And then finally, the 6th one is data destruction or ransom. So this is what the protestware in Node IPC did. So I'm not going to dig too much into this one, but you can see a bunch of obfuscated code here. And then the most important line is right here where you see that it's writing a heart emoji over every character of every file on your hard drive. Very friendly, very nice. So how can you protect your app? So first, I just want to quickly cover something that won't work here, and it's often brought up a lot. So this is vulnerability scanning. So vulnerability scanning is great. Everyone should do it, but I do think the security industry is a little bit obsessed with this. It's sort of like looking for your lost key under the light because it's kind of an easy thing to do, so everyone recommends doing it. But it's a little bit too reactive to stop an active supply chain attack. Vulnerabilities can take weeks or months to be discovered, and in today's culture of fast development, a malicious dependency can be updated, merged, and then running in production in days or even hours, which just isn't enough time for a CVE to be created and then make its way into a vulnerability scanning tool. So just to be really clear here, let's distinguish between vulnerabilities and supply chain attacks. So vulnerabilities are accidentally introduced by an open source maintainer. They're not intentional. They're usually mistakes. And then when they're found, a security researcher will publish a CVE, and the maintainer will fix it, and then you'll get this report that basically says, this version is bad, you should use this newer version which fixes the issue. Usually it's okay to ship low-impact vulnerabilities to production and fix them as you get to them, and most companies do have quite a backlog of vulns that they're trying to work through and fix over time. Supply chain attacks, on the other hand, are intentionally introduced by an attacker, and it's never okay to ship those to production. You must catch them before you install them or depend on them or really run them in any way. So you don't have really days or weeks to mitigate this issue. You need to catch it before you install it. So a vulnerability scanner won't catch the next supply chain attack. So back to how can you protect your app? So I have a few ideas here. This is not a solved problem by any means. This is something that I think the whole community is really grappling with. But I'm just going to share my kind of ideas for what we can do here. So the first one is to support open source maintainers more. 23% of open source projects have only one developer contributing the bulk of the code, and 94% of the projects have fewer than 10 developers, accounting for more than 90% of the lines of code. So we need to do better here. When you have maintainers that are overburdened and somebody reaches out and offers to help become a maintainer, it's not surprising that people say yes. They're dying under all the workload, and when someone offers a helping hand, we shouldn't be surprised when the maintainer says yes and accepts that helping hand. So I think if we can invest more in open source, then hopefully we don't have maintainers in such desperate situations. The second one is we should change how we think about dependencies. I think we really need a mindset shift around how we think about our dependencies. If you ship code to production, you are responsible for it. It doesn't really matter whether the malware came from code that you typed out on your keyboard or whether it came from code in a dependency. At the end of the day, it all gets bundled up and run in the same Node.js process. And so at the end of the day, it's your responsibility to make sure you're not shipping bad code to production. I think right now this is not how people think about dependencies. If you actually dig into the most popular open source license, the MIT license, you'll see that the very first line of it says, the software is provided as is, without warranty of any kind, express or implied. So those who are paying attention already know this is how open source works, but I think a lot of developers just assume that it's not their problem if it's in an open source package. Third, I think it's worth thinking a little bit about the right cadence to update dependencies at. Unfortunately, the common security wisdom is to always try to stay on the latest version, which increases the risks of supply chain attacks. Because the quicker that you update your dependencies, the fewer eyeballs that have had a chance to look at the code. You can't benefit from herd immunity if you're the first person to catch the virus. So how quickly should you update? Well, if you update too slowly, you'll be exposed to known vulnerabilities. If you update too quickly, you may be exposed to supply chain attacks. So really, there's just trade-offs here and no perfect solution. One interesting approach that I've seen the Signal Messenger team take in the Signal desktop app, which is an Electron app, is that they actually try to stay about 6 months behind the latest version of any given package, with the exception of taking CVE fixes, taking security fixes. That's one approach. But really, there's just trade-offs here and no perfect solution, unfortunately. Fourth possible solution is to dig deeper before choosing a dependency. So how closely should you really look at your dependencies? How closely should you audit them? Some companies take the approach of doing a full audit, so literally having multiple security engineers look at every line of code of every dependency before taking it into the project. This is a lot of work. It can be quite slow, and it can be quite expensive in terms of time and money. But it is sort of the gold standard for how to make sure that you don't suffer a supply chain attack. On the other hand, you can do nothing. This is what most of us are doing, frankly. If you do that, then you're vulnerable to the next supply chain attack. It's risky, and it can be expensive in a different way in terms of PR and just data loss and other damages. But at least you'll be in good company, because most of us are doing nothing right now. So I think very few of us, actually, we do have some things we look at when we pick dependencies. So what I've seen is, developers usually look at whether the dependency will get the job done. That's one very common one, obviously. Does it have an open source license? Does it have good docs? Does it have a lot of downloads and GitHub stars? Does it have recent commits? So is it maintained? Does it have types, maybe, right, or tests? So these are all things that are pretty quick to determine. When you go to the GitHub page, you can just kind of skim it and get a sense for if this package is something that you would want to use in your project. But very few of us dig deeper than that. I think in 2022, we need a new dependency checklist. We need to ask different questions before bringing a package into our project. So we should ask things like, does the package have an install script? If so, what command is going to run on my computer when I install this? Does it have native code? Native code is compiled and hard to audit. Does it talk to the network? Does it run shell commands? Does it read environment variables? Does it gather telemetry, i.e., does it phone home and send data about how you use the package to the, send data back to the maintainer about that? And does it contain obfuscated code? These are all questions that if you did answer these before selecting a package, you could dodge most of the supply chain attacks that we've seen in the news. Unfortunately, it's not too easy to look up this stuff about a package. You really have to dig in and do a bunch of manual work. And so I'll shout out the product that I'm building, Socket, because it is an attempt at solving this problem. It's a cybersecurity kind of platform that can help protect a repository from a supply chain attack. The way it works is we audit all the packages on NPM to look for different things that we can detect with static analysis. And then we provide that data to you to use in various forms. So one form is this free website that you can go to and look up a package and see like what capabilities does the package use? So in this example, the package is using install scripts and native code here. And so you can see, okay, does it make sense for this package to be using these things? In this case, it does, so nothing to worry about. Feel free to install it. But what about a different package that might be doing something sketchy? So this package here looks like it's a React component for showing kind of a loading overlay component over the page. But if you dig into its dependencies, you'll find that they have several issues. They have an install script. They gather telemetry about your application. They access the network, and a lot of other issues that you can kind of scroll through here. And if you click into any of these, you can jump straight to the line of code where where that behavior is taking place, and then decide for yourself, does it make sense for this package to be doing this? And finally, here's an example of an actual piece of malware. So for this here, this package is a typo squat attempting to get people to make a mistake and install it. And if you do install it, you'll see it's going to do all these things here. And if you click into, let's say, for example, the environment variable access, you'll jump straight to the line where you can see exactly what it's doing. It's taking your environment variables, and then it's sending them off to a URL down there with that HTTP request on line 46. So this is one approach you can use. I also think that it's not enough to just do research initially, because we also update dependencies quite frequently. So I know in my projects that I usually get 5 to 10 Dependabot pull requests on an almost daily basis. So we need something to keep up with this kind of constant churn of dependency code. And so I think we really need to monitor pull requests for the introduction of new dependencies that may be bad. And to do this with static analysis, auditing the dependencies on every pull request, to look for privileged API usage, obfuscated code, and a host of other things that you can detect with static analysis. And then once something is caught, then that's the time for a human to jump in and do a manual audit to really answer the question, does it make sense that this package is doing this? And that info should be put directly in PRs so developers can see it and act on it. So again, I will just shout out kind of the socket solution is this bot that you can install that will kind of go in and just leave a comment letting you know anytime a dependency does something suspicious. In this case, this is the developer installing a typo package. They've installed Bowserify instead of Browserify, which is a Bowser-themed fork. I kid you not. I couldn't figure out what it did, but the only code they changed is they add an extra bit of minified.js to your bundle. And I don't know what it does, but it's probably not what you intended to do. So it only has 300 downloads a year. So we call it out here so that you can fix it. And then here's a few other examples. Here we're detecting telemetry in the Next.js package and install scripts in Node.js. But I'd love to see more tooling do this and more approaches. This is just the approach that we've been working on. And finally, I think we should improve the JavaScript language itself, the Node.js runtime, and then NPM. Because there's a whole bunch of low-hanging fruit here that we should work on. And I'm actually really excited for Miles' talk to see what things GitHub has been working on in this regard. But my personal JavaScript security wish list would be, number one, allow maintainers to suppress vulnerability warnings in dependencies. This is so that we're not getting constantly overloaded with 100 or 200 vulnerable packages found every time we run npm install, which causes us to just get alert fatigue and to start ignoring it. This is not for supply chain attacks, but rather just for vulns. But I think that this type of tooling that constantly warns people about stuff that they're not going to actually fix is just leading to developer fatigue around security, and that's not good for any of us. And so I think if a maintainer knows that a dependency that they're using that has a vulnerability doesn't affect that package, then there should be a way for the maintainer to say, you know what, this doesn't affect this package. Please stop showing those alerts to my users. I think it would go a really long way toward reducing the alert fatigue. I'd love to see Node get Deno-style process permissions like -- allow net and the rest, so that you could run untrusted code in a sandbox. I don't think this is a complete solution because it's pretty coarse, and most real-world applications are going to need allow everything pretty much, allow all. But it is a step in the right direction. And then finally, I'd love to see per package permissions. There's a whole bunch of really interesting work in this area, like secure ECMAScript, ES realms, compartments, and even Node actually has an experiment called, if you look up -- experimental policy, you can actually see a pretty interesting experiment in Node around locking down the capabilities of specific packages to just what those packages need at runtime. And I think that would be pretty awesome. There's also 2 other things I'll call out, a project called LavaMoat and a project called Endo, both of which are kind of like userland shims of secure ECMAScript. And you can use those today to actually really lock down the capabilities of a third-party package. Unfortunately, there is like a huge performance hit today if you use those. And so it's only practical in certain high-value situations. But it is already being used in real-world places, such as in the MetaMask extension in the browser. So they put the actual crypto kind of logic code inside of a little kind of LavaMoat jail, I guess. So anyway, these are my kind of 3 things I wish that we could do as a community, and I think it would get us a long way toward improving the security. And I think that's all the time I have. So thank you for having me. This is how you can get a hold of me, and we're hiring at Socket if you're interested. Thank you.